The first missions of the Artemis program will arrive on the Moon in 2021 with 2 robotic landings through NASA's Commercial Lunar Payload Services Initiative. Astrobotic's Mission 1 Peregrine lander will carry 11 NASA experiments among its greater flight manifest. The destination is the basaltic plain of Lacus Mortis. Also scheduled for 2021 is Intuitive Machines' IM-1 mission to the southwest portion of Mare Serenitatis. Included among the mission's payloads will be 5 NASA experiments. Other precursor commercial partner flights will follow, including a robotic landing in Mare Crisium. Possible landing sites under consideration in Mare Crisium include the area near a horseshoe-shaped volcanic cone. Also under consideration in Mare Crisium is a site just south of Picard Crater. However, the focus of great attention for upcoming robotic and crewed missions is the dramatic landscape of the lunar South Pole, with its areas of perpetual shadow and reserves of water ice. The South Pole lies on the rim of Shackleton Crater, measuring 21 kilometers across and over 6 kilometers deep. Imagine standing on the rim of Shackleton, on a thin ribbon of light perched on a steep slope, plunging down into an inky dark, permanently shadowed frigid abyss 3 times deeper than the Grand Canyon. Extending from the rim of Shackleton toward De Gerlache Crater is a ridge that experiences prolonged illumination from the sun and therefore solar energy, features moderate slopes, and is in close proximity to permanently shadowed regions, making it an attractive candidate for future exploration. Also nearby, the summit ridge of Malapert Massif receives nearly constant sunlight while towering above adjacent regions of perpetual shadow, potentially preserving vast deposits of ice. The region of the lunar South Pole will be a key focus of our sustained human presence on the Moon. Looking further, our gaze inevitably takes us to Mars. This is a target of ongoing robotic and future human exploration. NASA's Perseverance rover is scheduled to land on February 18, 2021. Its destination is Jezero Crater, an ancient crater lake that measured 49 kilometers across. Jezero Crater was filled by rivers entering from the west and north. Their dry beds can be seen today. Water drained from the lake through a channel in the east, on the right of this view. Here we fly along the western inlet channel as it crosses through the rim of Jezero Crater. As the river entered the lake, it dumped its load of sand, mud, and gravel into a delta deposit on the floor of the lake. Perseverance will study this deposit and its contents. Looking further ahead, we are now identifying possible landing sites for human missions to Mars. Over 40 have been found so far, and we are continuing to add to the list. Not surprisingly, some of these sites are in Mars's Grand Canyon, Valles Marineris. Its walls expose the geologic history of the planet. Across its floor, we see sand dunes and deposits from the floors of ancient lakes that once occupied the valley. Many other candidate human landing sites are under consideration, including areas near extensive mid-latitude debris-covered glaciers. 2 much smaller worlds have also been subjects of great interest and activity this year. The near-Earth asteroid Bennu is currently being explored by NASA's OSIRIS-REx probe, which collected samples on October 20, 2020, from the Nightingale site seen here. As OSIRIS-REx prepared to collect samples from Bennu, researchers noticed several very light-colored boulders that were very different from the rest of Bennu's dark native boulders. These light boulders seem to have come from elsewhere. They match the composition of rocks NASA's Dawn mission studied from the asteroid Vesta. Japan's Hayabusa 2 mission explored the near-Earth asteroid Ryugu, deploying rovers at 2 locations in 2018 before collecting samples from the surface and subsurface in 2019 for return to Earth scheduled for December 6, 2020. You can explore all of these worlds and more using NASA's Solar System Treks family of web-based portals. View planetary surfaces as seen through the eyes of many different instruments aboard many spacecraft. Conduct detailed measurements and analyses of planetary features. Generate 3D print files for user-selected landforms. Interactively fly across planetary terrains. Create your own custom virtual reality flyovers. These are just a few features of NASA's Solar System Treks available at trek.nasa.gov.